Hello, pre-calculus students. Today we are going to talk about ellipses. So this is page 12 in your notes. So we're going to start out by, I'm just going to put up a few equations for you to look at. And I just want you to look at and compare, like, what do you notice about the shapes? What do you notice about the equations? You should pause the video throughout to kind of stop and think and try things on your own. So when you're looking at the graphs, you might notice, okay, I see two circles, right? These are the equations for circles that we've talked about before. And then these are ovals, and these are called ellipses. And I want you to compare the equations of the ellipses to the equations of the circles. You might notice they seem pretty similar. For example, the center, we get the same way. So the center is coming from what's with the x and what's with the y. So our center is at 2, 3. And this one, our center is at -3, 2. So just the same as we did with circles. The difference is in a circle, from here we get our radius and we go left, right, up and down 2, the square root of this value. And here we go left, right, up and down 4. But that's not what happens in ellipses. So what information in the equation is going to tell us how much to go left and right and how much to go up and down? So if you look under the x's, you notice a 4. And from the center, I go to the left and to the right 2. So I'm going the square root of 4 to the left and right. And from the center, I'm going up and down 4. And if I look here, there's a 16 there. So I'm going the square root of 16 up and down. In this one, same idea. From the center to the left and right, I'm going to the left and right 4, which is the square root of 16. And from the center, I'm going up and down 3, which is a square root of 9. So it's very similar to a circle, but it's different because it's almost like I have two different radii. Now, remember when we talked about the definition of a circle, we talked about having a single fixed point and then one equidistant, and then it's equidistant, all the points equidistant from that, the radius. In ellipse, the definition is a set of all points P for which the sum of the distances from point P to two fixed points is constant. Each of those two fixed points is called a focus, and the plural is foci. It looks like it says foci, but you pronounce it as foci. So each of the two fixed points is a focus or plural foci of the ellipse, and the distances from the foci to a point P on the curve are called the focal radii. So if you look at this ellipse here drawn on the left, the F1 and the F2 are the two fixed points. And the idea is if I pick any point on the ellipse, so here they have a point P, the sum of those two lengths is equal to the sum of these two lengths. And I could pick any point. So I could pick even like this point here, and this plus this is the same. Now, we derived the formula for circle last time, and it was pretty straightforward. When we go to derive the formula for an ellipse, it's much more complicated. So I have a situation here in example 1 where they tell you the equation to find the equation for the ellipse, and they give you the foci are at -4, that's -3, at -4 and 4. So when you label foci, you're going to call one F1 and one F2. It doesn't matter which is which. And it tells you that the sum from any point to each of the foci is 10. That's like that sum of the focal radii, so that we know that the sum is 10, and they want you to find out the equation. So we know that if we find like this is some point xy, if I go from this point to F1 plus this point to F2, that's going to equal 10. And so it's like I use the distance formula twice. Now, we're not going to go through taking that distance formula and translating it into an equation. I'm going to show you kind of what the process looks like. because it's not as simple as like, oh, I'm just going to square both sides and I'm going to get rid of the square root, because that's just not how it works. It's this big, long process where you'd have to move one over, then you have to square both sides. You would have to make a box to expand that. It's really long and tedious as you're expanding it. And then you end up with something that looks like this. So our center is at the origin, and there's a 25 underneath the X. So I'm going to go to the left and to the right 5. And there's a 3 under my Y. I'm going to go up and down 3 and then draw my ellipse. So we're not going to obviously go through that every time. Our idea, though, is going to be the same as what we saw on here. So the form that we're going to see for an ellipse, if our center is at the origin, is this. Right, so an x squared, a y squared, noticing that it was they were both equal to 1. And this is if the foci are on the x-axis. So if the foci are on the x-axis, it's going to be longer horizontally. And if the foci are on the y-axis, it's going to be longer vertically. Notice the only difference between the equations then are where the a squared and b squared are. Okay, so if it's longer horizontally, the a is the bigger number, so it goes longer left and right. And if it's longer vertically, the a is the second number. So in an ellipse, the a value is always the bigger of the two. Okay, so then that means that when you go to graph it, the a and the negative at a are the x-intercepts, the b and the negative b are the y-intercepts. Here it flips around. Okay, in each case, we have symmetry with respect to the x and the y-axis. We're going to call the major axis the segment with length 2a. So the major axis is the one that's going to always be the longer of the two. So then the other axis we're going to call the minor axis. And that's connecting the shorter side. So that's always shorter. And then the vertices are the points where the ellipse cuts its major axis. So when we talked about circles, we would always talk about, okay, what's the center, what's the radius? When we talk about ellipses, we've got a major axis, a minor axis, we've got vertices, we've got kind of more information going on. All right, now, if I take a look at example 2 here, we want to sketch the graph. Well, it's not set up so that we have the equals 1 on the right. So I'm going to divide everything by 100, and then I'm going to reduce. So this is x squared over 25 plus y squared over 4 equals 1. So I'm going to get it into that format. And then horizontal or vertical. What I'm asking there, is it going to be longer horizontally or vertically? Well, since the bigger number is under the x, it's going to be longer horizontally. Okay, and the reason why is the bigger number is under the x. That's my a value. Okay, and then shift. Is there a shift? What's the center? Well, in this case, or the HK, is just 0, 0. Now, this other stuff I really don't figure out until I've graphed it. So I'm going to graph this first. So my center is at 0, 0. And then this tells me that I'm going to go, because it's under the left, 5 to the left and the right from the center. So from the center, I'm going to go 5 left and 5 right. This 4 tells me that I'm going to go 2 up and down from the center. Okay, so then there's my ellipse. The vertices, we said, are the endpoints of the major axis, which is the longer. So vertices, again, are the endpoints of the major or longer axis, which in this case would be here and here. So at 5, 0 and negative 5, 0. If you wanted, you could write, you could condense this if you wanted to, plus or minus 5, 0. Okay, I'm going to come back to the foci. The major axis length, if this is 5 and this is 5, would be 10. The minor axis is up 2, down 2, so that's 4. For the foci, and I think it was on here and I didn't mention it. Yep. Okay, for the foci, the way that we're going to calculate the foci if the sum of the focal radii for each of its points is the constant 2a, where a is greater than c, we're going to use c to represent the foci. Okay, so this is my formula right here for my foci. And here's where it matters which is the a and which is the b, because the a is the bigger. So I'm always doing c squared equals a squared minus b squared. Okay, so when I go to get my foci here, this is my a squared because it's bigger. This is my b squared. So when I go to get my foci, it's going to be c squared equals a squared minus b squared. So c squared is 21. So c is plus or minus the square root of 21, which you can just put that into your calculator and get your decimal, which is about 4.6. Okay, so c is plus or minus 4.6. So when I go to write this, it's, I could write plus or minus root 21 comma 0, or I could write plus or minus 4.6, or you could write it as two separate points. But the foci are always along the major axis. So from the center, I'm going to go 4.6. I'm just going to have to estimate where that is to the left, and 4.6 to the right. And I label one F1 and I label the other F2. Okay, now an ellipse, just like a circle, can have a center other than the origin. So then its axis is not necessarily on the coordinate axis. And if you look at these equations, they look the same as the circle equation, except for they have the a squared and the b squared, same as what we were just talking about if it was at the origin. So if we take a look at example 3 here, it says sketch the graph. So I would look at this and say, all right, well, first, is it going to be longer horizontally or vertically? I see the bigger number under the y, so it's going to be longer vertically. The shift is the hk, so if you look up here, you see it's still the x minus h, y minus k, so this would be negative 3, 4. This 864 tells me I'm going to go 8 left and right. Okay, I know it's left and right, not only because it's first, but because it's under the x. Here, it's going to be that I go the square root of 100 or 10 up and down, and it's up and down and left and right from the center. So I'm not going to be able to fit all that on here, like going left and right 8 and up and down 10 when my scale is only out to 7. So I'm going to change this and go by 2s. And again, I'm going to graph before I fill in the rest of this stuff. So I'm going to go to the left 3 and up 4. Okay, and you should pause and try this on your own. All right, then I'm going to go left and right 8. So 2, 4, 6, 8. 2, 4, 6, 8. And then I'm going to go up and down 10. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And then you're going to draw your ellipse as best you can. Sometimes I feel like mine, especially the longer ones that are horizontal, sort of look like a lemon head, the lemon head guy. Okay, so there's my ellipse. My vertices are, again, at the top. They're the endpoints of the major axis, which in this case is vertical, so longer. All right, and so my coordinates, I know I went to the left 3, so I know my x value on both of these is negative 3, and then I was at 4, and from 4 I went up 10, so one's at negative 3, 14, and then again I was at 4, and then I went down 10, so negative 6. So those are my vertices. My major axis, I went up and down 10, so this is 20. My minor axis, I went left and right 8, so that's 16. And then for my foci, it's the square root of a squared minus b squared. Okay, this is my a squared. It's the one that's bigger. And then b squared is 64. So c squared is 36. So c is 6, plus or minus 6. So that means that from the center, I'm going to go, in this case, up and down. Okay, it's always along the major axis. So I'm going to go up 2, 4, 6 here. There's one focus. And then I'm going to go down 2, 4, 6 here. There's my other focus. So then my coordinates, it's that from the center, from this negative 3, 4, I went up and down 6. So I know both of my x values are negative 3. So from 4, I went up 6. That would put me at 10. And then from 4, I went down 6, that would put me at -2. And so then those are the coordinates of my foci. All right, so now let's move on and talk about, let's try another one. Now this one would have us normally complete the square to get it into that graphing form. I am just going to give you that equation. We're not going to deal with the tedium of completing the square on these. Okay, so this is what the equation would be. I'd like you to pause and try to graph that equation. Think about everything you need to think about. Okay, so this is going to be longer horizontally because the bigger numbers under the x, and the x-axis is horizontal. My shift, that would be 1, 3. So then, and this 9 tells me I'm going to go 3 left and right. This tells me I'm going to do the square root of 4 or 2 up and down. So from 1, 3, see, 3 left and right. So 1, 2, 3, and 1, 2, 3. And then what do we say? 2 up and down, 2 and 2. All right, so here's my ellipse. Okay, my vertices are the endpoints of the major or longer axis. So I can think, all right, I know I went to the right one and up 3, and these are the y value is 3 for both of these. And it's from the 1 I had gone to the left and to the right 3. So if I was at 1 and I went to the left 3, I'm at -2. And you can also just look at the graph. This is at -2, 3. And then here I was at 1 and I went to the right 3, so that's 4. My major axis, again, I went 3 left, 3 right, so that's 6. And then I went up 2, down 2, so that's 4. And then foci is a squared minus b squared. Again, a squared is always bigger. So c squared is 5. So c is plus or minus √5, which as a decimal is about 2.24. Okay, so from the center, I'm going to go about 2 1/4 left and 2 1/4 right. Okay, remember foci are always along the major axis. They always end up inside. You went the other way, a lot of times you end up outside. That's a kind of a clue that you looked at it the wrong way. All right, so now the way I'm going to write the coordinate for this one, because it's kind of a pain with the decimals, is I'm going to think of it as starting with the point 1, 3. So I start with the vertex. And to that vertex, I'm going to the left and to the right, the square root of 5. So that means to this x value, I have to add and subtract the square root of 5. And here's how I'm going to just write my foci. I'm just going to write 1 plus or minus the square root of 5. That's my new x value, comma, the y value stays 3. So that's another way to write it, especially when you have a decimal. That's a little bit simpler. If you think that's more complicated, then you could certainly write the coordinates separately. All right, now last couple of examples are, I'm giving you information about the ellipse and now asking you to write the equation for the ellipse. So take a look at example 5. This one, there's a picture drawn for you, and see if you can come up with the equation. All right, so I know the equation is like something with an x squared plus a y something squared, like they're fractions, and I know it equals 1. So I can kind of start with those bones. I know the center is at 3, 1. So this is -3 minus 1 because this is my h and my k. And then I need to know, well, okay, well, what goes under the axis? Usually I take what's on the bottom and I take the square root, and that tells me how far to go left or right. So now it's like, how far did I go left and right? And now I have to work the other way. I'd have to square it. So from here to here is what? 1, 2, 3, 4. Is that right? 1, 2, 3, 4. And so this would be 4 squared, or 16. And then how much did I go up and down? I went up 1, 2, 3, 4, 5. So this is 5 squared, or 25. And so there would be my equation. This is 5, and this is 4. All right, so then for the last one, I would suggest, because there is no picture drawn, that you draw a picture. Okay, so it says, determine an equation for an ellipse on the coordinate axis with a major axis length of 10 and foci at 3 and negative 3, 0. Okay, so 1, 2, let's see here, 3, and then 1, 2, 3, at negative 3. Those are the foci, and it says the major axis length is 10. Well, remember, the foci always fall on the major axis. So I know, like, somewhere along, I know this length here has to be 10. I know the center is halfway between the foci. So here's my center. And again, I could set up my kind of framework of what the equation is going to look like. Now, my center is at the origin, so these are just both minus 0. And I know the length of the major axis is 10. That means from the center, I must have gone 5 to the left and 5 to the right. So that means I have a vertex at 5 and another vertex at negative 5. So it goes something like this. Okay, so that this length here is 10. So because I went to the left and the right 5, under the x, because x goes left and right, I'm going to put 5 squared, which is 25. What I don't know is how much I went up and down. Remember that this is the a value, right? The amount you went left and right is the a value. So I know a squared is 25. Remember, c is the value that we use to represent the focus, or to plot the focus. So I know a and c, I don't know b. So I'm going to use that focus formula just a little differently. So I would have 3 squared equals 5 squared minus b squared. And then I would solve that for b. So this would be 9, this would be 25. I would subtract the 25. So that would be what? Negative 16 equals negative b squared. So b squared is 16. I don't even really need to, I could take the square root and say, I know b is 4, but then remember what's going to go up here is that I'm going to square it. So I don't need to do that. And I also don't need these minus zeros. So my final answer would be x squared over 25 plus y squared over 16 equals 1. But I think for those, it's really important to draw the picture. Otherwise, it's really hard to see what's going on. All right, so that takes care of ellipses.